Hey students, this is lesson 5.1. These are get ready represents some concepts that you're going to need in this chapter that you've learned in the past. I'll just do a couple real quick here. So we want to tell whether the given ordered pair is a solution of the equation. That means we want to substitute 1.5 for x and 0 for y. And we want to see if it's true. So if we do 4 times 0 plus 2 times 1.5, see if that's equal to 3. And that's 0 plus 3, and yes, that equals 3, so this is a solution. All right, to transform equations, solve each equation for y. That means I want to isolate that variable right there, y. So in order to do that, I need to eliminate this minus x, the way you get rid of a minus x using the addition property of equality. We're going to add x to both sides. When we do that, we get 2y equals 4 plus x, or x plus 4. And then we need to divide by 2 so that we eliminate the 2 but don't eliminate the y. So that'll leave us with 1y is equal to x divided by 2 is 1x divided by 2, which is 1/2 x. 4 divided by 2 is 2. Okay, comparing unit rates, transportation. A car traveled 360 kilometers in 6 hours. A train traveled 400 kilometers in 8 hours. A boat traveled 375 kilometers in 5 hours. Which had the fastest average speed? To do that, we're just going to compare these and turn them into unit rates. So I'm going to do 360 divided by 6, which is 60 kilometers per hour for the train. And then if you do the same thing with the other two things, you can compare. Graphing a function. So one way to graph a function is to get some values for the function to plot. So we've chosen some input values x here, and we're going to find the output values. So when x is -2, if I put -2 in for x and add 3, I get 1. When x is -1, if I put -1 in for x and add 3, I get 2. If I put 0 in for x and add 3, I get 3. And I see a pattern where it's increasing by 1, so I'm going to assume that pattern continues, and I'm going to graph those -2, 1, -1, 2, 0, 3, and so on, and I can keep putting points in there. And since we're graphing this function for all real numbers, I'm going to draw a line through those. All right, and now a little review of rate of change. We're going to learn about rate of change and slope today. The objective is for you to learn how to find the slope of a line, or in other words, the rate of change of a line on a coordinate plane. So circle the rate that matches this situation. Ron reads 5 books every 2 weeks. Now, if we want to talk about the unit rate for that, that would be 5 divided by 2 is 2.5 books per week. That's a different kind of, specific kind of unit rate. All right, rate is always a ratio. A ratio is sometimes a rate. A ratio may or may not compare to different quantities. A rate always compares to different quantities. And that's what we have right here. Rate uses division. Rate compares quantities in different units. How does the slope of a road affect a person's driving? The steeper the road, the slower the car would go, and let's adjust it. So the road affects rate. And what kind of slope would a beginner? A beginner would ski on a small slope, meaning like flatter slope. All right, finding rate of change using a table. The table shows the elevation of the hang glider over time. Is the rate of change in elevation with respect to time constant? What does the rate of change represent? So if we look closely at these values, you will probably notice that they are dropping by 35, and we get that just by subtracting any elevation by the previous elevation. And they're dropping 35 every time the time goes up by 1 minute. So my rate is the amount of change divided by how many minutes it takes, or negative 35 feet per minute. The negative representing a decrease in elevation. So what does this mean? This means that the elevation of the hang glider is decreasing at a constant rate of 35 feet per minute. Now you might say, does it matter which values I pick? Like let's pretend for a moment that none of these values were in here, but we know that the hang glider is decreasing at a constant rate. We still use those values to find that, and we could. Since it's a constant rate of change, it doesn't matter if I subtract 255 minus 360, I get negative 105, but that is for 3 minutes time, and I get that 3 minutes time by subtracting 4 minus 1. And negative 105 divided by 3 is equal to negative 35, which is exactly the same. All right, go ahead and pause here now if you want to try and get the answers on your own, and you can check back. I hope you're reading the problem and getting the most out of it. All right, we got another thing we have to do is learn how to find the slope of the line on the coordinate grid, and we're going to learn a couple ways to do it. One way is simply just find the rise over the run. So slope is a ratio of rise to run. And we can find the rise and run by identifying some points on the graph. And I can see the process right there. Those are some easy points to find. And if I wanted to label the points, I could, but I'm just going to show an arrow going up. That's my rise, and then an arrow going that way is my run. Now, an arrow going up would be in a positive direction, and so would an arrow going to the right. That would be in a positive direction also. So this arrow represents a positive 2 for rise, and this arrow represents positive 8 for the run. And then I just do rise divided by run, which is 8 divided by 2. Did that backwards, didn't I? 2 divided by 8, which is 1/4. And it wouldn't really matter what points I used on this graph. Since it's constant rate of change, I can use these two also. There's a rise of 1 and a run of 4, and we can see that we get the exact same thing. For this one, this line is increasing going in this direction. So what I mean by that is if I'm going to the right on the x-axis, the arrow is going up. So that's increasing. This one is decreasing. So that one's going to have a negative slope. And if you look at closely at the arrows that we make, you'll see that also. So I put in these dots here. And just choose any two of them, like maybe do this one. That arrow is going in a down direction from this point to this point, as this one goes to the right. So that rise is actually a drop of 3, and this run is 6, and so I'm going to do rise divided by run using those values. So I get negative 3 divided by 6, which is negative 1/2. All right, we're going to use this formula a lot. It's called the slope formula, and basically you can take any two coordinates and find the slope of a line using those coordinates. And it kind of makes sense because if we wanted to find the length of this arrow using coordinates, it's just the difference between the x-coordinates. And the rise, this length of this arrow, the rise is the difference between the y-coordinates. Once I have those two, I can just divide them, do the rise divided by run, and I have the slope. So we will subtract the coordinates to get the change in those coordinates. And if the denominator, if the x-coordinates are the same, that means when we subtract them, we're going to get 0, and the x-coordinates are the run, which is the number we divide by. So what's going to happen if we do that is we're going to get an undefined answer, because you can't divide by 0. So let's use that formula here. What is the slope of the line through f and g? And f is negative 3, 2, and g is 1, 5. Well, the slope formula says I can subtract the y-coordinates to get the rise, subtract the x-coordinates to get the run. Let's put that down here. And so I have to identify which is the x and which is the y. The first term is always the x, the second one is always the y. So that's my x1, y1, and then this will be my x2, y2. So subtract, and it really wouldn't matter if I called this y1 and this y2 and then this x2 and this x1, but I have it that way. So I'm going to do 5 minus 2 for my rise, and 1 minus negative 3 for my run. 5 minus 2 is 3. 1 minus negative 3 is 4. So my slope is 3/4. All right, what is the slope of these lines? Now these are kind of a special situation. If I use the slope formula here, I'm going to have to pause the video here and add a little bit more to it.